Hello and welcome to Computology Academy, and today we are going to discuss about the solar energy and the related waste that is being generated and how to manage that waste, the photovoltaic waste. So the solar energy is becoming popular worldwide because of the climate change issues, the environmental concerns, and because of the conference of parties that is going on each year. And many of the countries are switching from the conventional energy sources to the non-conventional energy sources and the renewable energy sources to cut down the carbon emission. So this topic is going to be very important from the GS paper 3 perspective for the civil services exam as well as in the state PCS exams, because the climate change and the environment and ecology topics are becoming the hot topics throughout the section of all the examinations, right? So the competitive examinations are focusing on these topics. So let us start here. And first of all, we will see that how does the solar energy is being generated. So here the solar insolation is basically used to convert the solar energy, that is the insolation that is coming to the earth surface from the sun, and that is to the tune of its amount is 2 calorie per minute per centimeter square, right? And this is also called as 2 Langley, that is the solar constant that is coming to the earth surface. So here this amount of energy is being converted, not exactly, but there are various other losses and the efficiency issues also. So very minimal of this amount of energy that is coming to the earth surface is converted to the electricity, and that is converted through the use of photovoltaic cells, solar panels. So here if you consider that how much of coal is needed for production of 1 gigawatt of electricity in the thermal power plants, then it is to the tune of 450 tons of coal that is required to produce 1 gigawatt of electricity. And if we tone it down, then 1 megawatt of electricity is produced with 450 kg of coal, and this is a very huge amount, and this is going to produce very huge amount of carbon dioxide and even other greenhouse gases. Those are there in the coal itself, right? So here this is calculated with the consideration of 40% efficiency, energy conversion efficiency, and this energy conversion efficiency is not so high in India. If you consider in India, then it ranges between 30 to 35% in different power plants, as well as the calorific value of the coal in India is also not so high, and because of that also this may go up. The consumption of coal, amount of coal for 1 kilowatt of or 1 gigawatt of the energy production may go up from 450 tons, right? And here if we go on to consider the installed capacity of the solar energy in India, then it is to the tune of 40 gigawatt. So you can understand how much of coal is being saved every day and how much less greenhouse gas emission is there every day, that is being reduced due to the solar energy. So here grid connected solar energy production is of the tune of 40 gigawatts, and this is the data for up to 2022, and out of this 35.6 gigawatts are ground mounted solar power plants, and the rest of the 4.4 gigawatt of the energy is produced from the roof mounted facilities, like small solar power plants which are installed on the office rooftops, malls rooftops, and various other rooftops. Even the individuals are also going on to introduce and install the solar power plants on their rooftops to meet their own necessities, as well as they are using the facility of meter in meter out type of metering units with the permission of the electricity board, and in that they are also providing the electricity to the grid also, whichever is excess and not needed by them to use, right? So here target is to produce 50% of the solar energy, or not the solar energy but the energy that is required by India by the year 2030 from the renewable sources of energy. Like it may be produced from the wind energy, it may be produced from the solar energy, it may be produced from the biomasses, etc. Whatever the renewable source of energy is available, from that India is targeting to produce 50% of its energy requirement by the year 2022. And the target is to make India carbon neutral or zero carbon emission will be there. The target is this, not will be there exactly. It is very ambitious target even to hear about that, by the year 2070. And it is a very ambitious target because if we consider that the current installed capacity is not more than 100 gigawatts, it is still less than this, because India at 75, it was target that India will produce 100 gigawatts of the energy required by India from the renewable source of energy, but India had missed the target. And right now, if we consider the target of 2030, then by 2030 India will need to produce 500 gigawatts of power by renewable sources of energy, and this will be only 50%. And with the passage of time, there is going to be the increase in the demand of the energy, and that will lead to more carbon emission, and that is why it is a very ambitious target. And in this also, what will happen, major chunk of the energy out of this 500 gigawatt will be produced from the solar energy itself, solar energy sources, right? And that is why we should discuss the waste that is being generated by the PV waste, photovoltaic wastes, and the management for that waste. So here, the waste generation, if we consider about the waste generation that is being generated from the PV waste, so according to International Renewable Energy Agency, IRENA, it has estimated that by the year 2050 there will be generation of around 78 million tons of photovoltaic waste globally. Global, this is the global estimation, not only for India, but India will be among the top 5 nations that will be generating the photovoltaic waste. And that is why we should talk about the waste management, solar waste management within India also, right? So India is expected to be the top 5 nation, and in the top 5 nations, the most probable nations will be India, China, United States, and some European countries. These are going to be the top 5 nations, right? And what is the situation in India? If we talk about the situation in India, then what is the situation? India does not have any firm policy to recycle or to manage the solar waste. And why India does not have any firm policy for that matter? Because India does not consider the photovoltaic waste as the separate waste, but India includes it within the e-waste. For India, e-waste, electronic waste, and the photovoltaic waste are the same thing. They are not considering the solar waste as the separate waste. And the wastes are generated in the operational condition also, during the operational period, as well as during the manufacturing period also. While manufacturing also, various discarded products are there which does not qualify the quality control, etc. Various things are there, because of which the wastes are generated during the manufacturing processes also. And here India does not account it separately. Whatever the waste management system is accounting the generation of electronic goods. So here the electronic wastes are being accounted, their amount is being calculated, their amount of is being recorded, but the amount of PV waste is not being recorded, it is not being considered as the separate waste, and that is why India is not having any exact data how much of the waste is being generated in India because of the PV waste. However, some of the NGOs are accounting it, are trying to have some data, generate some data so that they can pursue the government to make some effort to manage these PV wastes also. As well as India is not having any commercial recovery facility for the PV waste. The PV wastes are being managed by the e-waste companies only. The e-waste companies who are involved in recycling and other things of the electronic waste, these companies are recycling and they are managing the PV waste also. However, both of them are the different things. The solar panel wafers should be recycled in different manner than those of the electronic waste. In the electronic waste, various things are there: TV sets, mobiles, cameras, etc. Whatever you see, those are available in the market. But the solar e-wastes are, the PV wastes are completely different thing, right? And that is why India needs to have a different effort for that. And here India, if it is needed to have some effort, to put some effort in the management of PV waste, so Indian government did that. Indian government made a committee, mission, commission and omission, right? So here the committee has been already constituted, and the mandate of the committee is to evolve a circular economy for the management of PV waste. And how does they will evolve the circular economy? They will be focusing on reuse and recycle method of the PV wastes: collection, reuse or recycle, refurbish, whatever you say, or to extract the utilizable materials from that and the metals available in that, and thereafter reuse it, right? So that will be reintroduced back in the manufacturing system. And now if we talk about the waste, then how does the waste is generated? So the waste, most probable system, the main stream of waste generation is the end of life cycle. So let us see the solar panel life cycle. In general, the solar panel life cycle is estimated to 25 years. And if we say that when does India started manufacturing the solar panels, the PV materials, photovoltaic materials and equipments, then in India at large scale the manufacturing of such kind of equipments started around 2010, right? And still these companies, these manufacturing installations are indulged in mainly the assembly function. Most of the raw materials are purchased, most of the semi-finished goods are purchased from China, imported from China, as well as many of the firms are even importing the completely manufactured solar panels and they are rebranding it and selling it within in India, right? So here, if the manufacturing had started in 2010, then we can easily say that the solar waste, PV waste is going to be generated by the year 2035. Then why are we considered that now? So we should consider it now, because the only possible way is not this only, because it is only one possible waste stream through which the PV wastes will be generated. Later on, if we talk about the other streams, then there may be damage, and this damage may be during the manufacturing processes, maybe during the transportation processes. If you say that okay, the manufacturing has happened, then the transportation is going on, during the transportation also it could be damaged. And if it comes down to the location of installation in single piece in well and good condition, then the damage may occur during the installation process also. Or if the installation has also been done properly, then what will happen? There may be defects, some kind of defects, and those PVs could also go to waste. Next, discard. Many of the people may discard some of the PV equipments before their end of life cycle because of efficiency concern and various other things. Suppose that if the new technology, like the technologies are going on changing day by day in the mobile sector and the electronics goods sector, and the people used to change the mobile before the end of the life cycle of the mobile. Many of the people are so fanatic with the iPhones, obsessed with the Apple iPhones, that they can do anything to get the iPhone, because every year there are new technologies that are being introduced in the mobile systems, right? And that is why here also some kind of people might be like that. They will say that the efficiency of the system is not so high, so to produce more electricity within the same space, we should change the panels, and if they will discard in this manner, then they will go to the waste. These equipments will be wasted and they will contribute to the PV waste. So here, according to some NGOs, the PV waste has been generated in India is of the tune of 285 tons. 285,000 tons of PV waste has been generated in India till date, and this amount is going to increase in India drastically because the PV equipments are being used in India increasingly day by day. Many of the people are using the PV systems to generate the electricity. They are using the meter in and meter out method, so that they will reduce their electricity consumption costs, and all those things are going on there, because of which the PV waste is going to increase in India. And that is why the government needs to focus on the waste management of the PV waste. And here what is the need? So first need is that recognize the PV waste as the separate waste than the e-waste, so that proper focus will be there on the management of such kind of wastes. Next is to streamline the waste management in this sector. This sector is completely unorganized sector. There is no set method, there is no set system to collect the waste, to recycle the waste, to reuse the waste, to discard the waste, whatever it is going to be done with that particular category of waste, that should be streamlined in the PV sector also. And next is investment and incentives is needed to promote the PV waste management sector. Here what should be done? First of all, the government should invest in the technology development as well as development of some of the facilities for the PV waste management, to demonstrate that this could be also done profitably, and the people should focus on this to prevent the environmental degradation due to the PV waste. And later on, some incentives should be provided to the private sector to invest in the PV waste management system. And next is to producers extended responsibility, like it has been done in the plastic products and some other electronic goods also. Here the government is extending the responsibility of collecting the waste and managing the waste to the producers themselves, and same thing should be done with the PV waste management system also, because those are the people, these are the sectors who are well known with the PV waste. They know the technology used, they know how to use it, recycle it, refurbish it, and extract the extractable utilizable materials from the waste of the PV sector, and to reintroduce it in the manufacturing system. So they will be very helpful. Now I would like to inform you all that the UPSC General Studies Foundation course has been announced by the Computology Academy. That is going to be the foundation course for Civil Services 2023. This is going to be start on 28th of March. This is offline batch where the holistic coverage of the prelims comes mains syllabus will be there, and for further details you can get in touch with us on this mobile and the WhatsApp number or this landline number. And you can also follow us on our social media channels. This is our Facebook and Instagram handle, from where also you can get various informations. This is our Telegram channel, from where you can go on to solve various questions, practice questions, etc. And here, this is our website. If you want to register for the courses in an online mode, then you can go to the website and you can register for your course from there. And do subscribe our channel and press the bell icon to get notified whenever we upload new videos. Thank you very much and have a nice day.